Hello, my name is Mustafizur Rahman, and I'll be sharing some of my future research plans. So, the primary area where I am focusing currently is on quantum signal processing, various learning problems such as classification and forecasting, and some of the optimization tasks for communication. In wireless communication, two important layers in the TCP/IP are network layer and the physical layer. And I will primarily focus on the physical layer, especially in the context of quantum communication for future generation communication specifically, where the file layer will have two kind of part one is with the CPU or GPU connections and another with the QPU or quantum processing unit part. How the quantum information basically transfer from one place to other place. So the role of quantum channel as well as the role of the classical channel and their various impairments and analysis. Along that direction, some of the fundamental problems that I am focusing. One is on the encoding problem. So basically, given a functions or a particular waveform or a signal waveform that needs to be encoded and then basically transfer from one point to other point. So what are the various possible encoding techniques for the functions for the quantum hardware or the QPU? So along that direction, one of the standard techniques is the Hadamard basis set technique, where the functions is represented in the Hadamard basis set. And the natural choice of the Hadamard basis because of the availability of the quantum gates, specifically the Hadamard gates on the quantum computer. However, the complexity of encoding such scheme is of exponential order with number of qubit 2 to the power n to encode the similar number of points on a quantum computer. To reduce the computational gate complexity, we came up with an initial idea where the function can be represented as a diagonal Hamiltonian and approximated as a polynomial function. And the polynomial function has a natural set representation on a quantum computer using various multi-qubit quantum gates. And there are, of course, some trade-off between the error and complexity. So this is an initial study was investigated for the gamma and exponential family of functions and specifically applied for some of the chemistry problems. And it is quite interesting to see for various waveform design in communication system and for various constellation design, how this kind of encoding scheme can be helpful. Another directions I would like to explore is on the quantum time series problem, where we have a sequential time series data and the data points are correlated. And one of the interesting natural phenomena in quantum computing is the entanglement. And some of the initial studies that we have been doing is to explore the entanglement as a resource to understand the time correlation and try to understand certain signal model between the consecutive time data points. So there are some sort of parametric and non-parametric variants of the quantum circuits that we have been working on, and this is an interesting directions for various channel modeling and time series forecasting problem in communication. Another interesting phenomena, basically inspired from the physics side, is on the role of the quantum measurement in order to understand various memory capacity of a communication system. So typically on superconducting quantum computer, such as the IBM device, we have been studying various kind of architecture, and one of the architecture is the reservoir computing system, where we have a dynamic quantum system such as the Heisenberg-based model or the Eigen-Hamiltonian-based model, where we encode some sort of signals and we also take some auxiliary qubit and then instead of measuring the system qubit directly, which is a strong measurement where the quantum state collapse and becomes basically the information becomes classical. Instead of doing that, basically creating a coupling, basically strong coupling or the entanglement pair between the ancilla qubit and the system qubit, and measuring the ancilla qubit instead of the system qubit. And there are some sort of various quantum channels and various open system model, open quantum dynamics model between the system and ancilla. And there are some studies shown that the memory capacity depends on the coupling strength. And it is interesting in terms of communication theory, specifically to understand various memory-based prediction schemes, such as the Markov chain-based model, the particle filter, Kalman filter, such kind of things, whether these are possible or not. So this kind of physics-based model quite interesting. So in summary, the core objectives of my research will be based on like complexity efficient algorithm design in terms of the quantum various routines for 6G and next generation communication, algorithm design and analysis for some of the tasks like detection estimations or the tracking in presence of various hardware impairments such as the coherence time, readout error, coupling error, etc. in the communication quantum communication system, and also designing various quantum operators for some of the signal processing tasks such as filtering, classification, prediction, etc. Thank you.